Okay, so last time we're looking at predicting Ghana's economic health using classical machine learning, and we are continuing with that. This is in two sessions. We have the classical machine learning aspect and the quantum machine learning aspect. So we began with the classical machine learning approach to predicting the economic health of Ghana, and we are still on that discourse. So I think just a quick reminder, refresher of what we did last week. I talked about various macroeconomic indicators that could be utilized. And basically, the Bank of Ghana provides some data for some of these macroeconomic indicators. For example, merchandise trade flow, financial soundness, exchange rates, and commodity price. There are other macroeconomic indicators, actually. So we looked at the merchandise trade flows data set, and the data set size basically was 27 kilobytes with dimensions of 188 by 14. So it means that data set contains 188 rows and 14 columns basically. And then we saw that data set contained various columns like year, variables, January, February, March, all the way to December. So we also talked about merchandise trade balance, where we said the trade balance actually refers to the difference between the merchandise exports and the merchandise imports. So at the end of the day, if we have merchandise imports, merchandise exports, then we take the difference. So there's exports minus imports. That gives us the trade balance. So this trade balance could be computed over a specific period of time. Basically, it could be even a month or a quarter or a year. So we also talked about, so this is how the data sets look like if when we visualized it last week. We also talked about the fact that we can have what is known as a positive trade balance and a negative trade balance. So if at the end of the day, if a country's exports exceeds its imports, then it indicates that the country is selling more goods abroad than it is purchasing. So when you are selling more than you are purchasing, it's actually a positive trade balance, and that is going to positively impact the economic health of Ghana. So a country that wants to grow its economy obviously will have to make sure that it is selling more than it is purchasing, because as soon as you purchase more than you sell, then we are having what is known as a negative trade balance or trade deficit. So that is very, very important. And for a country like Ghana, we need to be able to tell by means of merchandise trade flow data sets, be able to forecast into the future and get to know, are we actually going um, to forecast to get to know what some of the predicted figures for various variables will be, so that we can put measures in place in order to do the right thing and to ensure that our economy is stable and all. So that is very, very important. It's important that we forecast various variables for the merchandise trade flows so that the economy can grow. So that now we also have the importance of merchandise trade balance. And one of the important is a good indicator of economic health. So a positive trade balance can signal a competitive economy with strong production and demand for its goods internationally. So you see, the merchandise trade flow data is very, very important because one, it is an indicator of economic health. One, it also strengthens the currency of this country called Ghana. So countries with a strong merchandise trade surplus often experience a strengthening currency. So that is very, very important. Also, this merchandise trade balance impacts on the GDP. the gross domestic product. So the trade balance is a component of the country's gross domestic product. So a positive trade balance contributes positively to the GDP, whilst a negative balance detracts from it. So it's always important that we try to forecast some of these things before they happen so that we can put measures in place to curb any potential um deficits or issues that might arise. So very, very important. I give out this workflow the last time. It said workflow of a classical machine learning algorithm using the long short-term memory, the LSTM model. We're basically going to prepare the data. We're going to train the model. We're going to make predictions. We're going to convert the Keras model to TF-Lite for mobile applications. So for generation of recommendations, we'll look at it much later on. So we talked about the LSTM, which is a kind of a recurrent neural network. We talked about all of this last week. So we just go straight to our code and begin from where we ended last time. All right. I hope you can see the Google Colab.
Yes, sir.
All right. So last time we imported some libraries and then we read the merchandise trade flows .csv and then went ahead to get the head of the data, that is the first 5 rows of the data. Then went ahead to get the last 5 rows of the data, which is data.tail. Then we described the data using the data.describe function, which gives us a count of the data, the mean, the standard deviation, and other values there. We also did what is known as data.info, which gave us the various columns in our file. Then we actually try to check to make sure that all the data that we actually load into this system corresponds or has the following columns in it so that we are sure that we are dealing with the right data in the right format. So after that, we just printed the shape of that filtered data. Then we created a function to replace zeros with the mean of the non-zero elements in the row because we realized that the data consisted of zeros for certain months. And in order to streamline or to pre-process the data, it means that we'll have to look at the months that have values for them. And then we add those values, strike the mean or the average, and then we use that values for the rest of the months that contain the zero values. So we are trying to avoid or remove any form of zero values in our data by using what is known as the mean of the non-zero elements in the row. Then we printed our filter data to see how it looks like. So at every point in time, you need to print out the data to be sure that we are doing the right thing. Then afterwards, we shuffled the data indexes. We calculated the sizes for the training and test sets. We split the indices into training and test sets. So this was the code we entered last week for splitting our data into training set and test sets. Then we printed the train data to see what is in there. Then we printed the test data to also see what is in there. So basically, you see that the shape of the training data is 150 by 14, and the shape of the test data is 38 by 14. So the training data is basically 80% of the data, and the test data is basically 20%. So are there any questions before I continue? Any questions before I continue?
So inside the data, if there are non integer or maybe float values, maybe strings, are you going to drop them or something like that?
The values are all numerical.
Okay.
Yeah. All right, Kwabena Granting, you can ask your question.
Yeah, look, Chris, I wanted to find out if we would consider doing like a why we don't do cross validation instead of splitting it into just two sets. I've heard that sometimes they split the data into three sets. So I wonder if sometimes is it more efficient simply to just split the data into two sets compared to when we have like when we have a cross validation set where the data is divided into three sets.
Yeah, so you can actually split into three sets as well. That is also okay. That is not to say that is wrong, but you can also split it in two sets and also go and use that. So this is more of let you understand how we can perform classical machine learning and all of that in simple terms. But then, as you said, whatever you are saying can also be done. So yeah, it depends on the whatever you are trying to do. Splitting in two sets does not make it wrong. It depends on the task you are trying to achieve as well. So you can equally do that as well.
Okay.
Is there any questions? Any other questions? There's no other questions. Okay. If there are no other questions, let me be very sure of the name of this merchandise trade flows to be sure that the name is right. Okay. Let me run this model all over again. Run all. So let's wait for some time for this to run, then we'll continue from where we left off last week. All right. So, what's the last thing we did? Shuffling of indexes. Okay, so let's progress. Oh, let's progress. All right. So what is the next thing we are going to do? The next thing we are going to do is to create a function that is who's going to create data sets. So let's put a comment here, function. So we're going to create data sets for training and testing in a time series or sequence prediction context. So that is what we are going to do now, because the data we are dealing with is actually more like a time series information. So we need to create the data set and make sure that the training and test set is in the time series prediction context. Other than that, we will not be able to predict our outcomes properly. So we have our function def create data set. Def create data set. Timestamp equals 1. So begin with a timestamp of 1. X, Y equals that. So for I in range of length of data set minus time step minus 1, we said A is equal to data set dot I lock So basically, this code is just for us to, as I said, create data sets for training and testing in a time series or sequence prediction context. X.append A dot values then Y.append dataset.ilog I plus timestamp dot values. Then we return np.array x and np.array y. Now let's set our time step to 10. So we say time step or to 12 because we are dealing with 12 months. So I think 12 is more appropriate. Time step equals 12. All right. So we now create the training and testing data sets. So X train, Y train equals create data set, train data. Then, so we have a create function, create data set function. This function we created is going to accept two parameters. That's the train data, the training data, and the time step, which is 12. Then the X test and Y test. Also, we have a create data set function that is accepting test data and the time step. So let's run this to be sure that everything is okay. All right. Everything is okay. In that case, let's print our X string to see if everything is okay. You can ignore the printing aspect, but usually it's good to print out to be sure that your data is in the right format before you progress. X train, X train is not defined. Okay. Let's see. Let's run this. An indent does not match an outer.
Look, I think it's the indentation where it is. It's inside the function.
Yeah.
Also, the X train and Y
It's
train, they are
not
also
defined.
inside the function.
Okay. Okay.
Too. The
So I
time
think
step
the
too.
X train and
The time step is also inside the function.
yeah, that is true. All right. So I think let's reprint this again. So we can run this and then run this. Okay. So that gives us the training data. We can equally display the test data as well to also see what is in them. All right, so we see our training data and we see our test data. It means we can progress or advance from this stage. So you can equally print out their shape as well. Maybe you want to print the X train dot shape. Also want to print the Y train dot shape. You can do that just to um, X train S test. So the X train has a size of 137, 12, 14, X test 25, 12, 14. Okay. So we have actually completed this process. So what we can do is we can also check for the data types of X train and Y train, X test and Y test, to be sure that they are in the right data type format. So let's look at that as well. So maybe can check the data types to confirm conversion. So let's print our X train.
Hello, Doc.
Yeah,
Please, I wanted to ask if the time series, if it's the same as the batch size.
the time series, you mean the 12?
Yeah.
No, it's not necessarily the same as the batch size.
Okay.
So, let's print the shape of X test. Okay, so we are trying to, let's see, this is working. Okay, so it's going to display that it's an object, which is okay. So that is okay. So this is for the X chain and then X test. Let's also check the shapes for the Y train and the Y test. I think the internet is kind of slow, that's why it's keeping too long, but we can check for the shape of Y train and Y test, and also check for the data types of Y train and Y test as well. So our next thing will be to, oh, it's taking too long to run. Okay, that's good. So we can equally check the that of Y train as well. Very well. So our next task will be to create a pivot, or basically we'll create a data pivot, and that data pivot is going to pivot the data frame so that variables becomes columns and each row corresponds to a year. So we are reshaping or restructuring the data to make sure that the variables now becomes columns and each row corresponds to a particular year. So we define a data pivot object. You'll say data pivot or data pivot dot pivot. Yeah, index equals year, columns equal variables, values equals January, February, March, all the way to December. So that is step one. Then we'll now flatten the pivoted columns so that you get a multi-index data frame where months and variables are columns. So the data keywords.columns So for a month, var in data pivot dot columns then we'll convert the data frame to a numpy array. In this case, we are looking at the target data y train. So y train because data pivot dot values dot reshape data pivot. So this data pivot dot values dot reshape is going to accept 3 parameters. That is basically the sample, the number of months, and then the number of variables we want to predict. So we know the data sample is already in data pivot because we have restructured our data. So everything now is in data pivot. So that is our sample data pivot. The data pivot dot shape. Then the next parameter is going to be the number of months, which is 12. And the next parameter has to do with 11 variables. Remember, I said we are predicting 11 variables. When I opened the merchandise trade flow data the last time, there are 11 variables we are trying to predict. So you realize that we have one variable here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 for 2023, 11 for 2022. So every year has 11 variables that we are trying to predict. Uh, so let's go back. So that is why we have 11. After we are done, we can print the shape of Y train and see. So whatever the shape of Y train is, we need to make sure. Let's see if this code is even working first. Okay, 19, 12, 11. So that's our shape of Y train. Yeah. So we should get something having a shape of 12, 11. As now I don't get a shape of 12, 11, then it means there's a problem somewhere. Now, the next thing we are going to do actually is to create a function to replace NANs. Now, sometimes you can have data and have NANs and zeros in your data and all of that. We need to find a way to actually handle that, even though we can handle them preliminary, but sometimes after reshaping and restructure, it is possible that some of these zero and NAN values might appear again. So you have to actually handle them. Let me see. This function be created already. If it's been created already, we can copy and paste. But if it's not created already, yeah. So we have this function there already. So basically, we can just copy and paste and probably do some modification to it. So def replace NAN with row mean. So let's do some modification here. So numeric underscore row equals pd dot series row. Here numeric row equals pd is the pandas object. I hope you remember that. So numeric. So row mean for this, we have non-zero mean because numeric row is not equal to 0 and numeric row dot not any would mean hope everything is okay. It's supposed to be a bracket here. Let me see. Okay. Okay. Then we have numeric row equals numeric row dot mask numeric row for 0 or numeric row dot is any non-zero mean Then we return numeric row dot values. Let's be sure this function
You can ask question.
is right. And there are no errors in our function. Okay, no errors. Then let's call this function in our data pivot object that we created, so that it can eliminate any n values in there.
Hello.
Yeah.
Hello, sir.
Yeah.
Please, I wanted to ask, is there any way to check either you have NAN and try to
Is that?
I said, do we have any way to check through your data set to see that you have and entries there?
Yeah. There's a way. There are ways to check your data set if there are entries in NAN and all of that. Nevertheless, just to be sure, you can still have the function in place in case there are any NAN values there, then it gets rid of them. If there are no NAN values, then you are good to go. You don't have any issue.
Oh, okay.
Yeah. So let's apply this function to our data pivot so that, assuming data pivot is a pandas data frame, then we say data underscore pivot equals data pivot dot apply, then the name of the function. Let's run the function. Let's run the axis. So let's run this to be sure it's okay. All right. So there are no errors, means we can progress. Now we can check for the shape of the data pivot. So print shape of data pivot dot shape. And we'll see. All right. So the next thing we are going to do is to calculate the number of training samples. So n train samples equals int length of data pivot times 0.8. You know, we have reshaped our data, so it means we need to calculate the number of training samples. So then we can try to calculate the n test samples as well. Well, that is okay. Then we have total so this will be that which calculates our test samples for us. If you don't want that, you could equally recalculate the test samples using a different format. So let's comment this code. We can say total elements total test elements equals data underscore pivot data pivot times data pivot equal total test elements equal total elements equals data pivot dot shape. Oh, okay, dot shape times data pivot dot. Right, let's rerun this. Okay, so next thing we are going to do is to calculate elements needed for reshaping. So expected train elements equals n train samples times 12, the number of months times 11, number of variables. Then expected test elements equals data pivot or shape 0 minus train samples times 12 times 11. Let's run this, we sure our code is okay. Then let's check if there are enough elements for reshaping. So just basically to print out the total elements to see what is in there, and also print out the expected train elements plus the expected test elements and see what figure we're going to get. So just print commands. So print total elements available for in data pivot total elements. Then we'll print. Let me just copy this so that makes my work faster. We'll print total elements required for reshaping. So that is going to be expected train elements plus expected test elements. All right, let's see. So the total elements available in the theta pivot 2508. Okay. So let's progress. Let's flatten data and reshape for training and testing. So data pivot the values dot flatten so x train because data pivot reshape 12 y train data pivot. So this will be right, but then we can also say data pivot flat y train S train. So we can equally copy the X train data into the Y train data. And that is what if you are assuming that the X train and the Y train are the same. So we can have an X test equals data pivot expected train elements expected train elements expected train elements plus expected test elements the reshape data pivot reshape Y train plus X test not copy. Assuming Y test is also the same as X test. Let's run this first to be sure we don't have any errors. Then we create a function to remove because sometimes because our data contains numerical figures, sometimes you might have some commas and stuff appearing there because and we're dealing with US currency, US dollars. So because a currency numerical figure, we have to remove any commas that might be present in our data because it's possible there might be commas. And also potentially because of the commas too, it can make the figure not to be a number and make it more like a string. And that can be problematic. So, but if there are no commas, then that is just a number. But as soon as commas come in there, then it becomes more like a string. So if you are very sure that you don't have any comments appearing in your numbers, then you can go ahead, you can actually skip this step. But if you are not so sure, then it is better you define a function to remove comments and convert strings to float in order to avoid any problem. So that is what we are going to do. So def remove commas data. So return np dot vectorize data. Okay. Let's run this. All right, function is okay. So after defining the function, you can now apply it on the X train, the Y train, the X test, and the Y test data. So how do we apply that? So we can say X train equals remove commas X train. The same applies for X test. Let's copy this for Y train and Y test as well so that we move fast. Remove commas. It could not convert string to float. Oh, okay. That is the variables. So you realize that the data also contains the variable names and all of that. So you have to find a way to actually eliminate those variables. Okay, let me see something first. Okay, so I mean the X chain was okay. How about the X test? That was also okay. All right. Let's look at the Y train and Y test as well. Y train, Y test. Okay. See, this was where the right. Well, we can look at that later. So let's just comment out that for now. Yeah. Y train equals okay. Let's run this. Okay. Nice. So we can perform some scalings and other reshapings and all of that way before we actually come and build our model. So it is very important we do that. Other than that, if we build our model, we're going to have some problem. So let's just do that. The reshaping and the scaling of data using the min-max scaling approach and all. Very, very important. So we can reshape data for scaling. So can say X train the reshape -1 X train the shape then we do likewise for X test. All right. Very well. Then let's scale our data. using the min-max scaling. In fact, there are other scaling approaches that you can use. So you can use the right scaling approach that you think best suits whatever you're trying to do. In my case, I'm using the min-max scaling. So I have x train scale equals s scalar x dot fit transform x train dot reshaped the same for y train. Sorry, the same for x test. Now it's going to say it can't identify this because we said this is x train, so means we need to, this must be x train reshaped and this must be x test reshaped so that we don't have any error. All right. Now let's reshape back to a three-dimensional. So we have x train scaled equals x train scale dot reshape or x train dot shape 0, then x train dot shape 1, then x train dot shape 2 for three-dimensional. Do the same for x test. X test scale dot reshape x text dot shape 0 x text shape 1 x test. Okay, let's see. Error. Tuple index out of range. In tuple index out of range. X train dot shape. Tuple index out of range. Let's look at the first. X train dot shape. Let's see. 0, 1, 2. Well, from this error, X train scaled equals X train scaled dot reshape. X train dot shape 0. X train dot shape 1. X train dot shape 2. Let's see what is happening. What is happening? Okay. So if we leave it at 0, 1 is working, but as soon as we bring the 2, then it gives us an error. All right. Anyway, let's see. We're supposed to put it in a three-dimensional format, but apparently it's giving us an issue. Let's put it in this format and see. I hope we do not get any problems as we continue. Anyway, let's progress. If we happen to get an error, we'll have to come back to correct this. It means this is more like a 2D instead of 3D. So ensure Y train and Y test are not flattened. So you can say Y train that's got scaled because X train scale dot copy and Y test scale dot copy as well. Then you can ensure the data is of type float32. So X train the scale equals np.array X train scaled D type is float32. The same for X test Y train. Yeah. So let's see if Y test won't give us any issue. All right. So you can check for the shapes. The shapes of the X train, the Y train, the X test, and the. So let's check for the shapes. So say print X train, scale the shape, print X test. Okay. So let's check for the shapes. Okay. What is the shape we are having? So our X train is 18011, X test 4811, X train scale 18011, X Y test scale shape 4811. So it means our X and Y shapes are actually in alignment. So we can begin to build our model now. So let's build our model. Let's build the LSTM model. So we say model consequential model.add LSTM units. Let's add 128 units. We can also add an activation and age. Our input shape equals 12, 11, because remember it's 12 months, 11 variables. So your input shape must be 12, 11. If our variables we're predicting were 9 in number, then our input shape would have been 12, 9. But since we are predicting 11 variables, then it's 12, 11. And remember, this 11 must correspond to this 11 we are having here. So this informs us as to the kind of shape this we feed into our LSTM model. So we can also add our kernel regularizer. We have to with a learning rate of 0.001. Then we can add a dropout layer. Maybe let's say the dropout 0.3. So dropout layer with a 30% dropout rate. Then we can add a dense layer. And the dense layers are used for the outcomes. So because we are looking at predicting 11 variables, so we need to feed the dense layer with the value of 11. You can also pass the kernel regularizer here with a learning rate of 0.001. Let's run this model and see what will happen. Remember is that perhaps we forgot a comma. Comma. Did I forget a comma somewhere? Okay, input shape. All right. C was never closed. That's so. Okay, open one, open two. Okay, let's see. All right. Very well. Now, after building the LSTM model, let's compile the model. Anyway, I hope I'm still audible.
Yes, Doc.
Okay, I want to be sure you guys are still following before maybe I might just be speaking to myself. So optimizer equals Adam. Learning rate. So model the compile optimizer. So what we can do is to define a custom loss function here. We can do that. And I think that can be done. But for the meantime, let's assume that the loss is mean squared error, but the loss is actually different from mean squared error. They are not the same. So we can actually define a custom loss function here later on. But for now, let's leave it as it is and continue. So matrix equals the matrix we are looking at. Let's assume we are looking at the root mean squared. Because for regression tags, you can't be using precision recall and all of those things. Those ones has to do with mean squared error, root mean squared error, and then mean absolute error, and so on and so forth. So let's assume our matrix is root mean squared error and then mean absolute error. Let's compile this and see. All right. Now, let's apply early stopping to prevent overfitting. So I'm going to just put everything in here. Early stopping to prevent overfitting. No, one way to prevent overfitting is to actually prevent early stopping mechanism, so that what it's going to do is that it's going to be monitoring the value loss, and then is going to make sure that overfitting is prevented. So let's train the model so well, let's just say history, because model, you can just say model of fit, but you can equally say this as well. So let's use train epochs of 50, batch size of 32. So we can have validation split and all of that as something in there, but for now, let's just leave that out. So we have the X train scaled and the Y train scaled. We can also specify validation data. And for the validation data, we can put the X test scaled and the Y test scaled. Yeah. So we can now output final metrics. So you can print a message after the training is done. A message like, okay, model trained. Just for us to know that our training is complete. I hope this training will take place without any error. Yes, it says what? Validation data is not defined. Okay. Name validation data. X test, Y test code. Why would you say that? Let's run this again. Validation data is not defined. So sometimes when you get an error, you can check for the error. You can go to, so those of you who get errors, you can go and check online to see if you can get any help from that as well. Because sometimes when you are coding, you definitely run into errors. So you need to be able to get solutions there. You can go to what is known as Stack Overflow and other places for help on certain errors that you are getting that you cannot rectify. Why is it saying this? Validation error. Validation data is not defined. Let me take this out and see something. Let me see something. Yeah. I think
Oh, sir, the validation data must be placed in quotation mark.
that the validation data must be placed in quotation mark. Is it
I'm
necessarily
guessing.
has to be? No, I think this is right. Well, I think I've already implemented this already. So let me just open what I implemented. Let's go down here. This has already been implemented. That is that same thing I've done. Validation data. So when you run the validation data, it is supposed to run 50 epochs. And then you have your loss to be that, mean absolute error to be that, root mean squared error to be that, the validation. So you get that for the training and that for the validation as well. So that is what we're supposed to get. Apparently, what we're running was not working, but then it's the same thing we have here. It's supposed to run. Yeah, it's supposed to run. Let me recompile all of this again and see. Probably there's something run all. That's much. But you see, it's still highlighting the validation data stuff, which should not be the case. Anyway, let's look at what I already did. Maybe there's something I left out. So after training the data, this is what you are supposed to get. You have your training taking place, and then you get some final metrics being displayed at the bottom here. That is after the 50th epoch, the final values are displayed in there. So that is how to actually build your model. After building your model, you can save this whole model because sometimes you want to actually call this model in your mobile application. All right. You want to call this model in your mobile application. Like you develop a mobile app and you want to call the model in there. It means you have to convert the model to that is a Keras model. You need to convert it to TF Lite and then you can make use of it. So basically, before we get to that, let's look at the training. Yeah, the prediction, sorry. So we can save our model, then we can go ahead to print the model summary and all. But what is more important to me is this part where the prediction is taking place. So first, let's ensure that X test has at least 3 dimensions. If we can ensure that, then we predict the next year value. So what this is doing actually is that it's going to predict values for the next year, that is the next 12 months, for all of these variables. So the trade merchandise data set had all of these variables. There are 11 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 variables in all. You store them in an array, and then you declare a loop that will run the number of months, also linked with the number of variables. Then you print out every month, and then for every month, all the 11 variables, you print out their predicted values. So that is the code you are seeing, prediction of the 11 variables for every month. Then when you are done, you can plot your training and validation loss. So you can plot your training and validation loss. Well, this is loss. So you realize that for month 1, it predicted that, oh, the merchandise export less trade balance is this, the merchandise import non-oil is that. All the 11 variables, going to make a prediction. For month 2, the same, you're going to make a prediction. Month 3 is going to make a prediction. Month 4, month 5, month 6, month 7, month 8, month 9, month 10, month 11, month 12. Predictions are going to be made for a 1-year period. Then you can now display the graphs, maybe the loss graphs, the mean absolute error graph, and the root mean squared error graph. You can display the graphs as we are seeing them. All right. So that is the code to actually do the prediction. And then let's look at down there. You can convert your Keras model to TF Lite for mobile applications. So this is the code to actually do that. So you just load your Keras model. After loading the Keras model into the object model, and you pass the model to this particular setting, then you set your converted experimental enable result variable equals true. Then you use TensorFlow select ops. All right. You spell out your select ops. Then you disable the lowering of the tensor list ops. Then you convert the model, that's the Keras model, to TF Lite model. After doing that, then you save the model to a .tf Lite file. Because after converting, it doesn't necessarily mean that it's saved into a file. What have you converted actually is still here in this object. So you need to actually save it to a file called maybe CLSTM merchandise trade flows model.tf Lite. To save it to a file, and then you can print a message saying model converted and saved to CLSTM merchandise trade flow underscore model.tf Lite. So you see, you get a message indicating that the model has been saved. And that is how to actually save your Keras model to a TF Lite file, which can be used in a mobile application. Yeah, so those of you who want to probably use models in your mobile application, you have to convert them to TF Lite. If it's web application, then you'll have to convert to, I think, .js file before you can use them on the web. So that is how to actually build a LSTM model for this merchandise trade flow data we had. So in effect, this is all about classical machine learning. It's just a matter of trying to get your data, preprocessing the data, making sure everything is okay, passing the data to a model. The model trains the data, and then we output certain matrices here and there to see if they are performing well or they are converging well and all of that. And then after that, we can save the model as a .tf-lite file if you intend to use them in a mobile application. Yeah. All right. So any questions? So next week, we'll actually be taking a look at what is known as quantum machine learning. We'll take a look at quantum machine learning and how, in fact, what we are going to do next week will be similar to what we did today, but this time around there'll be some variance here and there because we're looking at quantum machine learning. So yeah, so this is what we're doing for next week. But whatever we did today, if you have any questions, you can
Please,
go
I
ahead
have a
and
question.
ask them. Yeah.
Please, I have a question, Doc.
Yeah.
I realized that you chose batch processing to work on the data. Is it necessary to always use batch processing in all machine learning tasks, or is this a special case? Why batch processing?
You mean the training of the model?
Yes, please.
Yeah, as part of the parameters, you are to specify a batch size. So the batch size actually depends on what you are dealing with. You can specify a batch size of 16, batch size of 32, a batch size of 64. It depends on what you are trying to do. But then usually, I know that the batch size of 32 is usually used for training your model. That is mostly what is used.
Okay, thank you.
Any other questions? Are there any other questions?
Hello, Doc. Yeah, is it possible to have your notebook before our next meeting?
The notebook, I don't know, but I learned the videos on the platform, the e-learning platform. So if you want to access the videos, follow with this tutorial and everything, it is possible to follow easily without any issues. As for the notebook, I'm not really sure. Maybe I'll have to discuss with the organizers and all. But I'm sure that should not be a problem. I can easily give out the notebook as well.
Okay, thank you.
Okay. Thank you very much, Dr. Nimbe. I think we got a collab file. You can share the link for them to have access to it. It's just a collab file. So, and also thank you for joining the meeting today. For a few announcements, if you've not met your mentor, please contact or send us an email so that we'll send an email to the mentors to meet you. And also, you've been assigned. Each group has been assigned. Apart from the mentors, we have monitors like myself and Lucas help with the project and also to make sure things are going on well. So if you've not met with any of them yet, you also have with them to meet them. As usual, the videos will be uploaded on the platform or YouTube. So if you don't see it on the platform, that means we'll put it on YouTube and share the link with you. Thank you again for joining. See you next week.